Hello everybody, welcome to iScholar. I'm your physics educator Shivani. So today in this class we are going to prepare some very important questions for your board exam from the chapter electricity. Okay, so let's get started students. Okay, so the first question which we have is, it is given that we have a filament which draws a current of 0.5 ampere. Okay, so let me tell you students, whenever any question you have in your board exam, the first thing which you have to do is just write whatever is given to you. This will make your answer look very good. So you have to attempt the question in the same way. You will write the current is 0.5 amperes. Calculate the amount of charge flown if it glows for time. Time is given to you, that is 2.5 hour. Okay, so pay attention to the units. If it is mentioned as 2.5 hour, make sure you convert it into second, because this is the common mistake done by students. So multiplying it by 60, because 1 hour have 60 minutes. Now converting this into seconds further, again multiplying by a 60, this will give us the value in seconds. So now when we multiply the 60 into 2.5, that is 36 into 2.5, that would be roughly 9.123 seconds. So yes, when you will multiply this, you will get the result. Now what is asked? You are asked with the calculate the amount of charge, and we know that students, current and charge are linked in such a way that current is equals to charge per unit time. You need to current is given, you need to calculate charge. This is 0.5 into charge into T. So from here you can get the value as charge flowing into this filament would be, just multiply these two, that is 0.5 into 923. So that would be, if you will multiply 0.5 into 9000, that would be 4500 coulomb. Again, a tip which I want to give you is, make sure you write the unit behind it. If you are talking for the charge, make sure you write coulomb after it. That is important. Do not miss it. Okay, so I hope you people got this. Let's just come to the next question. Okay, similar to that question only, in this session we are going to have mixed type of practicing. That means we'll be having some good questions, some tough one, and some easy one also. So let's see for this. It is given 15,000 coulomb is required to deposit on 1 mole of copper. Okay, so if we have, I'm writing what is given to us. If we have 1 mole of copper, we will be having 15,000 coulomb. Okay, on 1 mole of copper solution, find the time to deposit 0.2 moles. Okay, now if we have 0.2 moles, you have to calculate time, so that if you have 0.2 moles, for the current 5 amperes in flowing into the solution. Okay, so first thing which I want to know is, if in 1 mole we have this much charge, so how much charge are we going to have in 0.2 moles? So for 1, it is 15,000. So for 0.2, that would be simply 0.2 into 15. Now when you are going to multiply this, how much you are going to have? That would be something 1, 2, 3, 4. So when you have 0.2 moles, so you are going to have 30,000 coulomb. Clear? Now current is given to you, that is current value is clearly given to you, that is 5 ampere. Charge is given to you as 30,000 ampere. You can easily calculate the value of T from this, which is asked in the question. You will be writing current is equals to charge per unit time. Current value is simply, you will write it over here. The current value is 5 into the charge value is 30 divided by time. So from here you can just get the value of T as, this will go in over here and you'll get it as 6,000 seconds. I hope it is clear to you. Again, the tip 1, do mention the unit along with it. Now coming to the next question, I hope this question is clear to you all. Okay, so next question is a heater is drawing a current of 10 ampere for 5 minutes. Calculate the charge flowing in the heater. So again, this is a similar question, and this one is homework for you all. You have to solve this question and write the answer in the comment box. Okay, so coming on the next question is a very good type. It is given that work done in moving a charge 5 coulomb from a point A to B is 80 joule. If a potential at the point is 25 volts, what is the potential at the point B? Okay. So first of all, we'll like to explain what is potential. So let me just tell you, there are two things. First one is potential at any point A. In the second one, we are going to discuss potential difference between 2 points. How we define for the first one? This is potentiality. So how we say that? If we have a point A, so how we are going to define potential? That is, if we have a Q amount of charge, brought this from infinity. By infinity, you can understand to be very, very far away point. So when we bring a charge Q from infinity to this point A, the potential would be defined as simply work done in bringing the charge from infinity to the point A, that is, you will write work done divided by the amount of charge, that is Q. So you will write potential at the A point would be simply work done in bringing from infinity to a point A divided by the value of the charge. Again, this definition is important and is asked in the CBSE exam. Okay, so coming for here, next is potential difference, which as the name specifies, it is denoted between 2 points. So we'll say potential difference would be as simple as that. Work done in bringing a charge from A point to B. It is like you have two positions. The charge is initially at A point. Work done in bringing the charge from A to the B point. You'll write it as work done in bringing over here divided by the unit charge. So I hope these two things between potential and potential difference is clear to you all people. Coming on this is find the potential at B point. It is given. Okay, so again writing all the values which are already given to you in the question. Work done is given as 80 joule. If the potential at A point is this, okay, so we'll be writing, we need to calculate potential at B. E is mentioned, that is 25 volt, is equals to work done per unit charge, that is 80 by 5. Now what is 80 by 5, students? I hope everyone might be knowing this. This is 1 and 616. So we'll be writing VB, potential at the point B, is 25 plus 16. When you will mention this is 25 plus 16, that is 41 volt. It is 1 volt. Am I clear with this? Okay, so coming on to the next. Okay, now very important question. In such type of question are quite probable. That is, they'll give you a diagram and they can give you many parts, and these things can be asked in a similar way only. Okay, so let us come to the question. First, effective resistance of the complete circuit. Okay, so let us just figure out how many resistance do we have. Students, so this is the first resistance we have, and these two are the next resistance which we have. So in short, there are 3 resistance in total. Okay, so one is 4 and another one are 8 and 8. Okay, so doing for the first part, I'm writing, see, can I say that these two resistance, that is, they are connected between the point C and D. Both of these resistance are connected between the point C as well as between the point D. Can we say that these two are in parallel? So we know that the parallel value, the resistance for the parallel is given as Rp is equals to these 8 and 8 are in parallel. So in combinedly, they will be having 8 by 2. That is value of resistance divided by the number of times they have came. So it is 8 by 2, which is 4 ohm. Now for the total resistance, we have these two in parallel plus this one in series. So what would be the total resistance? This is 4 ohm along with series of these resistance, whose value we can clearly say that is also 4 ohm. So students, can we see that the total value of resistance is 8 ohm? So I am going to write over here. Okay, so the value of R total is, I am writing it as 8 ohm. I hope this part is clear. Next is potential difference across the 4 ohm. Okay, so they have asked us the potential difference between these coordinates, E and B. Okay, so how we can do? We know that the potential difference formula can be written as, from Ohm's law, we clearly know the fact is potential is equals to I into R. We need to calculate potential difference across this. So we'll be writing potential across these points is equals to current divided by the R value, which is 4. So students, we need the current value which is passing from here. So how can we get the current value? Can I say that the total voltage in the circuit is equals to the total current passing from the circuit into the total resistance passing from it. So we are going to have the total voltage is 8. The current value we need to calculate into the total resistance, which we just calculated right now, it is 8. So from here, can we get the value of total current passing from the circuit? That would be 1 ampere. Again, make sure students, you write the unit along with this. So the current passing in whole of the circuit is 1 ampere. 1 ampere is passing from this and going. So now we got the value of current from this, so we can write voltage is current is 1 into 4. So the voltage across this part will be given as voltage is okay, so the value of voltage will be given as would be given as simple as that. You will write it as this would be 4 volt. Once got, now we'll come over here, the next part, that is power, or we have calculated this. The next is power dissipated in 4 ohm resistance. We are going to calculate this D part, that is power dissipated in the 4 ohm resistance. So we know that the power formula is simply I square into R. Or you can write this formula as to be voltage into I, that is, we are writing the value for power, which is given as voltage passing from that circuit into the current. So we have to calculate the power dissipated in 4 ohm resistance. That is the value over here, the voltage over here, we know that the voltage passing is 4 into the value of current which is passing from here is 1. So again we can get the value of power to be 4 watt. Okay, coming to the next slide. Difference in the ammeter reading, if any. Now you should know, students, what is ammeter. Ammeter is a device that measures the value of current passing from it. So now we have 2 ammeters showing in the circuit, that is the first ammeter E1 and the second ammeter, which is E2. It is asked, do we have the same reading in these or the different reading? Okay, tell me, students, can I say that this is a complete one track or these all are connected in series? And we know that the current is same in the total series circuit. So whatever current will be passing from A1, the same amount of current will be passing from A2 also. So in short, A1 and A2 are going to show the same readings. I hope this part is clear to you all. Okay, so coming to the next slide. Again, a very important question, and in fact this question have been asked also in the exam 2020. Okay, so what is given? You have been given a graph between the current and the voltage, and there are three values, R1, R2 and R3 values are given to you. You have to choose that, okay, you have to choose that which resistance is bigger or are they equal. Okay, so let me tell you a bit theory. Whenever such graphs are given, you should know one thing, that whatever is given on y-axis, here it is I, so I'm writing I divided by whatever is written on the x-axis. So we'll write it over here as V. Whatever is written on y, whatever is written on x is equals to. Now use the formula and tell me what would be it. Whatever be on the y, whatever be on the x gives us the value of slope. Now using the formula, tell me what would be this value. So we know that the formula which we have is Ohm's law, which is V is equals to IR. From here, I can just simply see that the current divided by the voltage is equals to 1 by R. So can I say that the value of the slope is 1 by R? Okay. Now from this again, can I say that more be the value of R, greater be the value of R, can we say that slope would be less? Or can we say that the graph which have the least slope is going to have the maximum resistance? The graph with the maximum slope is going to have the minimum resistance. Okay, so from this, now can I say that this R3, the R3 one have the maximum slope? So logically, students, tell me R3 should be the minimum of all. Yes? Okay. Now tell me for R2. R2 have the minimum slope of all these. If R2 slope is minimum, again can we say that if R2 is the minimum slope, can we say that R2 slope is minimum, so can we say that the R2 will be maximum value? So just writing over here, the R2 value would be maximum. R2 is maximum. Now it is very easy for us to write. R2 resistance is the maximum one. This option goes by this, and R3 is the minimum value. Again, this option completely satisfied. So you can just choose this option B. I hope it is clear. Moreover, the extra thing which I want to give you in this question is, if the examiner just gives you the same question in the way, he just changes in the way. That is, V coordinate over here and I coordinate over here. The only change which you have to do is, you have to go by this formula. So if they change the coordinates, the slope in that case would be written as R. More be the resistance, more would be the slope. I hope this question is clear. Okay. So coming on the next question, in the next question it is given that identify the switch that on being closed will cause the fuse to blow. Okay. So what is happening for this fuse to blow? One thing which you should know is, this fuse blows when either there is an immense amount of current in the circuit, second, or the system have been short circuited. Okay, so by short circuited I mean that both the terminals of the wire or both the terminals are connected to same potential, or if anyhow you just complete the circuit in such a way, these all are connected to the same potential. Let me see over here. So in this question, can I say that when switch 1 will be on, it won't create much change. When switch 2 is on, it is just connected to the bulb. Will just help with the bulb to glow on or off. But when we do this switch, when we just close this switch, what is happening? You are completing this circuit in the way that this whole part is having the same potential. These all are connected in such a way that each and every point is connected to the same potential, or the circuit is shorted. Now we know that when the circuit shorts, then the fuse just glows. So we'll say that in this case the fuse will blow. Okay, so the next and again a very important question, what is given? You have to calculate when the heat produced is minimum. Okay, and what changes you can do is, you are given with 3 resistors, 1 battery. You have to draw the circuit so that the cell which is connected to 12 volt and the total heat is minimum. Okay, so writing the formula for the heat, that is V square by R into T. V stands for voltage, R for resistance. We all know this. Now for the circuit, if heat have to be minimum value, if we are going to write that heat is the minimum value, can we say that the resistance logically have to be the maximum value? When the resistance is going to have the maximum value, the heat will have the minimum value. Now, how can we have that the resistance to have the maximum value? How can we combine it into the circuit? So, for sure, we know that whenever all the resistance are connected in series, whenever they all are connected in series, we can just say that whenever all the resistance are connected in series, so this case, the resistance value is going to come the maximum. So in this case, when they all are connected in series, the maximum resistance would be got. And if we have the maximum resistance, which means that the minimum heat. So logically, we'll write over here, we are given 3 resistors. So we'll just calculate the value of total R, that would be 10 plus 10 plus 10 ohm. So we are going to have the net resistance value to be 30 ohm, and what is required in the circuit, you have to draw the circuit diagram. So just draw keeping all the resistance in series. So these all resistance which I plotted in series along with the battery whose value is given as 12 volt. I hope this statement is clear to you all. Yes? Okay, so coming to the next slide. Okay, so next slide is again a very interesting question and easy one also. So let's see how to do this. It is given Priya have a copper wire and an aluminum wire. These both are of the same length. Can the resistance of 2 wire be same? Can we have the same resistance for both the wire? Okay, so we know that resistance is given as rho L by A. If length is same, let's suppose area is also same, but since these wire are made up of different material, one is made up of copper, other one is made up of aluminum. So we are going to say that this resistivity would be different for all. Resistivity is a property of the material, what material you are using. So this would be different for all. So we'll say that since resistivity value for copper and aluminum is different, we'll see that resistance is different for both. Am I clear with this? Okay, coming to the next slide. What is electric current? See, such easy questions have also been asked to you. Now, what is electric current? Also, I'll give you a tip in the same question. Whenever they have given what is electric current, first of all, write for the definition what you know. That is rate of change of charge. Rate of change of charge. Charge flown in the circuit. Charge flown in the circuit. Okay. Now, after you write the definition, what next thing you should write is, write the formula. That's the key point. Write the formula, whatever it is. For example, here we'll be having current is equals to charge per unit time. So first I wrote for the definition and then I wrote for the formula. Third thing, which will make your answer very good, that is write the unit. If it is asked what is current, write the unit for current. That is the SI unit for current is ampere. That is, you'll write it by capital A. You write this by capital A. Okay. So by just adding these points, you can make your answer very good. Okay. Next question is, a potential difference of 12 volt is applied and the resistor value is 6 ohm. You have to calculate the value of current. So using the Ohm's law over here, V is equals to IR. That is, V stands for voltage, I for current and R for the resistance. So we'll be writing voltage is 12 volt is equals to the current value which we need to calculate, the R value 6. So from here we are going to calculate the value of current which would be 2 ampere. Again a tip, do mention the unit along with it. Okay, so coming to the next slide. Okay, so the last question for this session is define resistivity. So everyone know what is resistivity, how can we define it? Resistivity is an intrinsic property of any element. By intrinsic, I mean students, internal. Intrinsic property of any material, of the material. Intrinsic property of the material which shows that how strongly it is going to resist the path of the electron. Intrinsic property of material which shows that, or which tells that how strongly this material is going to resist the flow of current. Okay, so that is it. Moreover, you can also add one more point, that every material have a different resistivity. So if you have a material copper and aluminum, both of them would be having different resistivity for them. Okay. So that is it for the today's class. Moreover, we'll be having another session in which we'll be discussing some more important questions for the electricity chapter also. Thank you all.